At one time, I can pick one. Good, fine. So sorry guys for wasting 5 minutes of your time. Okay, so it's absolutely right, Aisha. Okay, so we have one is let me so yes. So let me pin my video right. Okay, so one is going like this, right? So one magnetic field is one current is in this direction. So what is the direction of the magnetic field? What is the direction of the magnetic field? One is going like the screen and coming out. So we have this one. What is the direction? Yes, Mariam and Aisha. What is the direction?
Your voice is breaking.
My voice is breaking. So can you hear me properly now? Can you
Yeah.
guys? Yeah. So this question, right? Let me bring that question again. So this one. So you guys can see that one is right. This is in what is this is YZ plane, right? So one is in YZ plane it is and this is in XY plane. So you guys tell me that yes. So one is going like this. One is going like this. What is the direction? Yes, guys. What is the direction if the current is going like this? What is the direction? Please tell me. Yes, Aisha, Mariam, what about the direction? Why you guys are not? I direction. Okay, so you see this is going like this. So this is minus I or I. Left or right? Right is I, left is minus I. So which one?
Left
I,
side.
left, right? So left is minus I, right? This is
Yeah.
going like this, so left. So magnetic field is in minus I direction. Okay. And the other one is like this. So this is what direction?
J.
Z direction, right? J. Oh, you said J.
Yeah.
Yeah. So other one is other one is like this. So J direction. In XZ plane, so J direction. Okay. So these are the two directions that we have, right? Yeah. So this one is J, right? This one is J, and this one is minus I. So this is the message. Okay, so they are telling us to. Okay, so this one is right. This one is minus I, and this one is what? This one is J. So you have two magnetic fields, right? Where is that? So magnetic field is that root is that one moment. has informed me that from the next classes, you guys have to switch on the videos. Okay, so please, from the next classes, right? Please, you guys switch on our videos. Okay, so the first magnetic field is, or first current is this, right? Going like this. So this one has this magnetic field direction, right? And this one, so this one is this, right? So this is this direction. Okay, so this is minus I and this is J. Okay, so then this is B of I, right? B of I is whatever. So this is mu naught I by 2A, right? And this is R, and this is G hat. And B of 2I, this is mu naught I by 2R, and then what? Minus of I. So if I calculate the magnetic field, this would be mu naught I by 2R minus I, and plus of mu naught I by, this is 2R, and then this is 2I, right? So this is 2I and this is IJ. So if I calculate the magnitude, this would be as you have written, right? So this would be 5, okay, 5 or mu naught I by 2. This is because of this, right? So this is I component, this is J component. So this is how you have to write. Why did you take bi square plus bm square, right? So this is the reason that you calculated this. Is this clear, Aisha and Maria?
Yes.
Okay, similarly in this question, so we have two parallel lines, right? So for this case, we have to find the magnetic field at the middle point. So for this 2.5 ampere, for 2.5 ampere, what is the direction of magnetic field? Yeah. What is the direction of magnetic field? Let's say this is XY plane. The wire are in XY plane. So what is the direction of magnetic field?
Minus I.
Uh, minus I. So P of 2.51. Okay. So this is, we put our uh, so this is XY plane, right? So if we put our finger in this direction, so this is in the right hand side, it is in which direction? Inside or outside? Yes, guys, inside or outside?
Inside.
What this one? Where would inside? So this is what direction? Yes, guys.
So your voice is cracking.
My voice is breaking. Am I audible now? What is happening with my voice? So is this clear now?
Yes.
Okay. So what would be the direction? Aisha and Mariam, please. Direction is very important. This is inside, right? So you guys have said inside. So inside is what direction? Plane is XY. This is X, this is Y. Right? Inside is, this is what direction? Z, and this is what? Inside.
Minus Z.
Minus Z. So this would be whatever this magnetic field is. So mu naught I by 2 pi A, and this is minus K hat. Right? This one is. And then we have V of what? 5 ampere. So this is in the left hand side. So what would be the direction, guys? Aisha and Mayam, you guys tell. In the left hand side, what would be the direction? Yes. Yes, guys. We have solved
Inside.
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 Mariam is saying inside. Aisha, what is your answer? Yes, Aisha, what is your answer?
Inside.
Inside. Okay, so we have this one, right? If we are calculating the magnetic field in the right direction, it is going inside. But if we are calculating the magnetic field in the left direction, so what is this direction? Inside or outside? You guys check and tell me. You put your pen, right, and put your thumb in the direction of the pen and check the left hand side, right? Put your palm in the left hand side and check whether it is pointing out. So where it is pointing out, guys, inside or outside?
Outside.
Outside. Aisha?
Outside.
Outside, right? So this is how you guys check direction. So we have talked about the direction, right? Okay, so this would be outside and this would be outside. So outside is what direction?
Okay.
K.
K, right? So this is the K. Now, if I calculate the magnetic field net, so this is vector sum of these two, right? So this would be what? This is positive one. So mu naught and this is 5 ampere one. And 2 pi and 2.5, whatever, this is meter. Okay, so this is meter. And K hat plus of this is mu naught I and then what? 2.5 ampere. And this is what? 2 pi and A is 2.5 and minus K. Am I correct? Am I correct?
Yes.
So that is why your this is 2, right? This is 1. So we have 2 mu naught by 2 pi and minus of mu naught I by 2 pi and then K hat. So that is why this 2.5 is in minus, right? That is why this is in minus. Okay, because it is in minus K direction, minus K direction. Understood? Yes. Clear, guys?
Yes.
Yeah, so you guys can also solve this. So this would be as you have solved exactly the same. So mu naught I by 2 pi common and 2 minus y once. This is mu naught by 2 pi, right? And what is mu naught by 2 pi? So magnitude is mu naught by 2 pi. What is mu naught by what is mu naught? What is the value of mu naught, guys?
And raised to minus 7.
What 10 to the power minus 7. Mu naught by 4 pi is 10 to the power minus 7. Right, Aisha? So mu naught
Pi.
is, yeah, mu naught is 4 pi into 10 to the power minus 7. So this is 4 pi into 10 to the power minus 7 divided by 2 pi. So we have 2 into 10 to the power minus 7. This is the answer, guys. Right? Yes. Aisha, yeah, so very good that you are trying these questions. And yeah, Mariam, you should also try these questions. Okay. So we guys saw that, yeah, uh, there are some things that we need to do in these problems. Understood, everyone? Is everything clear? Yes, guys.
Yes.
Okay, so now let us do what we did, right? So okay, so we understood that whenever the velocity of the charge is perpendicular to the magnetic field, then the charge will follow a circular trajectory. It will follow a circular path. And whenever it is following a circular path, which means that magnetic force is providing a centripetal force, right? So we calculated the centripetal force and then calculated the time period. So time period was 2 pi m by q, right? So please remember this, that time period is 2 pi m by q. Okay, so remembering this, let us, right, so let us understand about the third case, that V is are making an arbitrary angle theta with the magnetic, right? So we have the third case is that we have this, so we have this magnetic field, and the charge is so the magnetic field is in x direction. So this is magnetic, right? And charge starts to move in here. So what it will do is that, so charge is moving with some, so it is moving with some angle, right? So in here it has some velocity. So this is magnetic field, right? This is making an angle theta. Okay. So this theta will have a tangential component, right? This is the parallel component. So this is V parallel, right? This is velocity. Velocity is making some angle with the magnetic field. So this is tangential, which is V parallel, and then this is the perpendicular. This is the perpendicular velocity, right? So what will this perpendicular velocity will do? Yes. What will this perpendicular velocity will do, guys? Tell me what will this perpendicular velocity do? Yes. So this perpendicular velocity is with the magnetic field. So what will this perpendicular velocity will do?
Outside centripetal force.
Yes. What did you say, my Aisha? Yes, Aisha. Yeah, yeah, yeah. Please, whatever your answer is, please tell me again. Act absolutely good, good. So this perpendicular velocity will make the charge to move in circular motion. Right, absolutely good. So this will make it to move in this circular path. But we have this parallel, right, velocity. So what this will do is that it will shift this charge in this direction. So it will move in circular direction, but it will follow a helical structure. So it will move like this. So it will complete a circle, but it will shift, right? It will shift in this direction due to V parallel velocity. So this will follow a helical structure, helical path, right? So it will move, it will follow a circle but move in the magnetic field direction, in X direction. Is this clear, guys?
Yes, sir.
So then we have a thing which is called pitch. So the distance between two consecutive circular paths, this is called pitch, right? So what is, how do we calculate this pitch, right? So between the consecutive pitch, it completed one rotation, right? Between the consecutive pitch, it completed one circular motion, right? So what was the time period of one circular motion? What was the time period? Yes. What was the time period, guys?
2 pi m by q.
2 pi m. Absolutely right. So 2 pi m by q. Right. This is the time that it takes to reach here. So it started from here, then it completed the circle and it reached here. So this is the time it takes to reach here, t time. And velocity is how much? In this direction, velocity is how much? Yes, velocity is how much in this direction? Yes, guys. What is the velocity in pitch direction? Parallel. Right.
So your voice is cracking.
Again, my voice is cracking. Yes, Aisha, is this happening for you also?
Yes, a bit.
Uh, for you also, my voice is breaking.
Now it's fine.
Yeah, maybe check your internet, Mariam, right? Again, so okay, so maybe there is some internet issues in your side. Okay, Mariam.
Yes, sir.
Okay, so did you guys understand that in this tangential direction, in the direction of magnetic field, so in the x direction, in the x direction, velocity is v parallel, right? So then pitch would be how much? Pitch is uh, pitch is distance between two consecutive circular trajectory, right? So, what is the formula of distance? What is the formula of distance? Yes, guys. What is the formula of distance? Distance is speed into time, right? Yes.
Yes,
So v by t. Yeah, distance is v by t. Maria, velocity by time.
Sorry,
One.
sir, I got confused.
Yeah. So distance is speed into time, right? So distance is pitch, speed is v parallel, and time is one rotation, right? So then we can calculate pitch, which would be equal to, this is v parallel, right? And this is what? So this is 2 pi m by q, right? This would be pitch. So let us do one problem, and you guys will understand that. Yeah, so, okay, you guys first note it down, right? And if you have any questions, so please ask. Okay, first you guys note it down, please. And whenever you guys want me to scroll down the screen, guys, okay.
Sir, can you please scroll down?
Thanks.
Okay, so you guys have seen the spring, right? So let me, if you stretch the spring, right, then the circular form would be distorted, right? So then it will have a larger pitch, right?
Yes, sir.
Okay, and if I ask you that when the pitch is zero, when the pitch is zero, so what would be the path of that charge when the pitch is zero? What would be the trajectory of the charge? Think about it and tell. So if uh, pitch is zero, so let us come back to this part. Pitch is zero, right? Which means that what is zero? Mass cannot be zero, charge cannot be zero, magnetic field cannot be zero, right?
Mm,
So V parallel is zero, right? V parallel is zero, right, guys?
that's
So which means that this is theta, right? This is V parallel and this is V perfect. Okay, so this is V perfect. So V parallel is V cos theta, whatever is this V is V cos theta, and V perpendicular is V sin theta. So V parallel is zero, which means that cos theta is zero. So cos theta is zero, which means that what is for pitch zero? Parallel is zero, which means that cos theta is zero. So when is cos theta zero? When is cos theta 0? Yes, guys. When is cos theta 0?
90.
90 degree, right? Okay, so assigned assessment. Today's so in the previous class, what did you guys take? Okay, so yeah. So as Aisha said, theta is 90. So when theta is 90 degree, which means that this is the direction of magnetic field, and if this is velocity is perpendicular to this magnetic field. So what would be the trajectory, guys? Yes, what would be the trajectory? Yes, if theta is 90 degree, which means that magnetic field and velocity are at 90 degree. So what would be the path? Guys have forgotten. So if velocity is perpendicular to magnetic field, then it would be circular path. So if you guys can see from here that if pitch is 0, then it will circulate in its circular path, right? So it will follow a circular path. Understood?
Yes,
Yes, sir.
Yeah. So this is what I wanted to point out. That if pitch is 0, then you don't have any parallel or parallel velocity. You only have perpendicular velocity. So if you only have perpendicular velocity, then it will follow a circular path. So this was okay. So let's do one question and then we'll move on ahead. Find the pitch of a charge of let's say 3 microcoulomb, right? Traveling in a magnetic field of magnitude, let's say 5 Tesla in the having mass, let's say 1 milligram. Okay. So this is the question with the velocity of 20 meter per second and making the angle 60. So this is the question. Okay. You guys find out what would be the pitch. So you guys find out, calculate the pitch and tell. Okay. You guys have what? You have Q, right? This is 3 microcoulomb. You have magnetic field, which is 5 Tesla. You have mass, which is 1 milligram. And you have velocity magnitude, which is 20 meter per second. And then you have theta, which is what? 60. So you have all these things. You guys calculate and tell me what is pitch. Yes, are you guys calculating?
Yes, sir.
Yeah, please calculate and tell me the answer. This angle is with the magnetic field. Okay, so and also let me increase the question. So also calculate the circular trajectory. Uh, Radius of the yes. Did you guys get the answer? Aisha and Maria, did you guys get the answer?
One answer.
Okay, still calculating, guys. So we have right. We have a charge which is following this kind of path, right. So we have to calculate this pitch and the radius of this circular trajectory, right. So for pitch, what would be the velocity? For pitch, which velocity component we will use? Yes, Aisha and Maria. For
V
pitch,
parallel.
parallel. And for radius, which velocity component will you use? Yeah. What gives the circular trajectory? Which velocity? So the radius is given by V perpendicular, right? And what is pitch? So pitch is
V
pitch
parallel.
and QB, or what is that? 2m by QB. M pi, what is that? So 2 pi m by Q. So this is 2 pi m by Q, right? And what is radius? What is radius, guys? Yes, what is radius?
V parallel.
Oh, for V radius, okay, so you got, Aisha has got 0.041 into 10 to the power 6 meters, right? This is the pitch that Aisha. Good. Mayam, what did you get? So this is what, Aisha? Radius you already know, right? So for radius, magnetic force is centripetal force, and this is perpendicular one. So this cancels and R is MV perpendicular by QB. So this is MV perpendicular by QB. This is the radius 0.010 into 10 to the power minus 6. Okay, so Aisha is getting 0.010 into 10 to the power minus. So let us check. So this would be the radius, right? Radius we already know. So what is radius? We have already calculated. Radius is, where is radius? This is MV by QB. But this V is perpendicular, right? This V is perpendicular. So in this case, this V would be perpendicular. Parallel one will give you pitch, perpendicular one will give you circle. So what is V? Let us calculate what is V perpendicular and V parallel. So this is our V and this is theta angle. So this is V parallel and this is V perpendicular. So V parallel is V cos theta and V perpendicular is V sin theta. So V is 20 meter per second cos of root 3 cos of what 60, which is 20 into cos of 60 is half, right? So this is 10. So this is 10 meter per second. Who got disconnected? Oh, Mariam got disconnected. And this is 20 and sine of 60. So this is 20 root 3 by 2. So this is 10 root 3, which is 10 into 1.7. So this is 17 meter per second. Is this clear? So this is V parallel and this is V perpendicular. Now we will put all the values. So this is what? Which is 10 meter per second into 2 pi, right? And m is what? M is 1 milligram, right? Which is 1 or into 10 to the power minus 3 gram, but we have to change it in kg, right? So this would be 10 to the power minus 6 kg. And then what do we have? Then we have charge, which is what? 3 microcoulomb and magnetic field 5 Tesla. So this is 3 microcoulomb and 5 Tesla. So this 10 to the power 10 to the power minus 6 cancels. And what is cancelled? So this is 3.14. So we have 20 and into 3.14 divided by 50. So this is 2. Right. So we have what? So this is 4 pi and by 3. So this is 12.56 by 3, which is 4 and 1 and 8, something like that. So this is meters. So this is the pitch, guys. How did you get 10 to the power 6 and minus 6? Yes. Is this clear, guys?
I got
Yes,
4.18, but then I didn't, like the next step I thought was wrong, so I did not calculate the power.
Yeah, you are close. So this is 4.1. Yeah, so this is 4.1. Yeah. Only 10 to the power 6. Yes. Okay. And then we have this radius. So you guys calculate this radius that you right. So radius is r, which is mb perpendicular by t. Yes, Mariam, you got. Oh, so this was correct, right? 41866, but some right. So some difference in power. So this is 10 to the power 1, 2, 3, 4. Right. So some 10 to the power 4 will cancel and then this will be correct. Yes, yes, correct, correct. So you guys please note it down and then did you guys note down this question? Okay, please quickly note it down and then we'll talk about the next. Who got disconnected and rejoined? Yeah. Yes, Mariam, are you saying something? Because I cannot hear you. Your mic is.
Yes, I was going to say that your video was stuck, but I got disconnected before that.
Yeah, maybe there is some issue with your internet. Okay. So did your internet provider say that now it is okay?
Sir, he had come a few months ago, so because a few months ago also we had the same problem. He told that it's a problem of the router. So we
Yeah.
changed the router to, now, but I don't know what is happening.
Yeah, please
It is
call him
still
and
showing not explained.
yeah, please call him and say that please come and check. Right. So then he'll be
Yes,
able
sir.
to, yeah, then he'll be able to properly check what is happening, right? So yeah, maybe there is some wiring issue or something like. So which connection do you have? Optical one or the copper one? Yeah.
Sir, I didn't
So
understand.
yeah, so you have two kinds of Wi-Fi connection. One is the optical fiber one, right? And the other one is this what copper wire one. So for the speed and connectivity, optical fiber one is the good one. So I guess you have this fiber one, right? But that is very
I think
fragile.
so, sir.
Yeah, but that is very fragile. So if you fold or the wire, then it will break. So, but it doesn't happen with the copper wire. So maybe there is some wiring problem. You call your because yeah, you are giving him the some amount of money you are giving, right? So tell him that why it is not working properly, right? Okay, because you are facing
That's what
yeah, yes, uh, yes. So please note it down, guys. Okay, I wanted to complete Florence force and all. Oh, so I took extra time. Yeah, you guys, please note it down and tell me whenever you have finished. Noted, everyone. Yes, Aisha and Mariam noted.
also.
Yes, sir.
Okay, so now we know about all kinds of magnetic force, right? Now let us talk about the so Lorentz. What is Lorentz? Right. So whenever when the charge is moving in the presence of electric field and magnetic field, right? Both, then it will experience both the electric force and the magnetic force, right? Combinedly, that force will be called Lorentz, right? So the force exerted by on the charged particle due to the electric field and the magnetic. So it is the sum of those forces. So if you guys remember, okay, if you guys remember, so if we have this electric field, right, and this is the charge. So what is the electric force? Do you guys remember? What is the electric force? Yeah, force on charge particle in the electric field. What is the electric force? Okay, you guys have forgotten. Are you guys not revising? So it will experience a force in this side, which is QE. Is this so now you remember? Do you guys remember this?
Yes, sir.
Yes, sir.
If we have a negative charge, so this will experience a force in this direction, which is minus Q, right? So this was the electric force. Okay. And if the charge is traveling, so let's say charge is moving like this, right? In the presence of magnetic. So then this charge will feel this is the velocity, right? This is the velocity. So in here, this is electric field, which is QE. And in here, this is the magnetic field, which will be what? What is the magnetic field, magnetic force? Yes, guys, what is the magnetic force?
So could you repeat your question?
Okay, so you have the magnetic field in this direction, and the charge is traveling, right? So what would be the magnetic force?
You be into the
Yeah, QV cross, right? So this is cross product, right? This is a vector product, right? So Q, yes, QV cross. This is the magnetic force, Maria. Already forgotten, right? This is what we calculated. So let's say that we have, let's say we have a charge, right? So let's say we have a charge. It is moving in the presence of electric field and then the magnetic field in this direction. Magnetic field in this direction. Okay. So this is magnetic. So then what will happen is that this is, let's say, the uh, this is velocity of the charge part, right? So it will experience the electric field, which is QE, and it will experience the magnetic field, which is QV cross. So then the Lorentz force, this would be what? Electric field force and then magnetic force. So this would be equal to QE plus QV cross. This is what we call the Lorentz. Is this clear, guys? Is this clear?
Yes, sir.
Yes, sir.
Okay, please note it down and then we'll do one question based on. So please note it. And whenever you guys want me to scroll down the screen, guys, yes, whenever you guys want me to scroll down the screen, guys,
Done, sir.
then, then please.
None, sir.
Done. Okay, so now let us do one question. Mariam, noted.
Yes, sir.
Okay, so before we do that question, let me ask you this question about what is uh, what is I cross J? What is I cross J?
Okay.
K. And what is J cross I? Yes. What is J cross I?
Minus K.
Minus K. Okay, good. So now, very, very good. So you guys remember this cyclic property that we talked about, right? So whenever we go clockwise, right? Whenever we go clockwise, not clockwise. So whenever we go clockwise, that would be positive. So I cross J would be K, and J cross K would be I, and K cross I would be what, J. And similarly, if we go anti-clockwise, right, then this is I cross K. So I cross K would be minus J, and K cross J. This is minus I, and what? J cross I. So this is minus. Good. So this we already know. This is the property of the cross product, right? Okay. Keeping that in mind, so let's say that find the Lorentz force experienced by the charge of 4 microcoulomb, right, in the electric field of, let's say, 3I plus 2J, right, volt per meter, and moving with velocity 2I plus 3J, right, in the magnetic field I, let's say, plus 2. So you guys calculate. The question is that calculate the Lorentz force. Please calculate and tell. Also calculate the magnitude of Lorentz. Please, you guys quickly calculate and tell me the answer. Because, yeah. So, and velocity is in meter per second, right? All the units are SI units. Magnetic field is Tesla. Yeah, please note down the question and calculate the answer. So let me simplify the question. Right. So this is only 4 coulomb, right? Don't think about the small charges. So this is 4 coulomb. And whenever you guys have calculated, please tell. Yeah, anyone got the answer? Yes, got the answer, guys. Yes, guys, got the answer.
No, I was still calculating.
Oh, still calculating. Okay, Mariam, what about you?
So even I'm still calculating.
Yes, anyone? What is happening, guys? This is only vector. These are only vectors. Anything that you are getting. Okay, so who's got 11 into 10 to the power minus 6? 11 into 10 to the power minus 6. So this is what? Magnitude or this vector? This is what Mariam is getting. Okay, Aisha, what did you get? Yeah, what did you say, Mariam?
Sir, you changed 4 microcoulomb to 4 coulomb, sir.
Yeah, so this is coulomb, not microcoulomb. Right. I changed
Yes,
the
sir.
question because it was okay. So if this is coulomb, then it is 11.
Sir, I'll calculate again.
Oh, you are calculating. Okay. Okay. So Aisha, what did you get? Yes, Aisha, did you get anything? Correct or incorrect? Don't bother about that. Right. At least try. At least think about the question. What we need to apply. Okay. So yes, Aisha, did you get anything? Put the value of Q. Okay, so okay, yes. Please calculate, guys, and okay, so what I will do is that I will calculate and you guys check the answer. Okay, this is what is Lorentz force, guys? This is QE plus QV cross V, right? So Q is common. We should take Q common, and this would be E plus V cross V. So now everything is given. Q is 4 Coulomb. Electric field is 3I plus 2J. And then velocity is 2I plus 3J. And then cross product of 3I plus 2K. Is this yeah, so did you guys reach this point? Yes? Okay, so I got 4J minus 28K. Good, good. So you got 4J, so Aisha got 4J minus 28K. And yeah, so we know that. Let us draw it here. I, J, K. Whenever we see cross product, so we draw this diagram. In this way, it is easy. So this is 4, 3I plus 2J. And then this is 2I cross 3I. So I cross I is 0. Now we have 2I and 2K. So that is 4. And I cross K. That is minus J. And then we have 3J and 3I. So this is 9. And JI is minus K. And then what do we have? 3J and 2K. So which is 6. And J and K is I. So this is I. Right. So we have these ones. So this is 4. This is 3I plus 2J minus 4J minus 9K and plus 6. So what do we have? We have 6 plus 3, 9I and 2J minus 4J. So minus 2J and minus 9. So then this is into 4. So this is 36I minus 8J and then 36 minus 36K. So this would be the answer. This is our Lorentz force. Okay, so don't bother if you get the wrong answer and the right one, Aisha. Okay, so it is always encouraged to just do the calculation, right? So yeah, this is the answer, right? So did you guys understand this part?
Yes,
Okay, so 3I, 9, and J and I minus 9, 3 to the 6, J, K. So this we have 6, 3, 9, and then we have minus 9, which is here, and minus 2J. So this one. This is the value of the Lorentz force. And if we want to calculate the magnitude, so this would be of 36 square plus 8 square plus 36 square. So this would be the magnitude. You guys solve, right? At your home, you guys solve. So you guys quickly note it down. Right, quickly you guys note it down. Question we have already noted. Note down this part. And if you guys have any doubts, so please ask.
Sir,
Yes, yes, Mari.
sir, I wanted to ask about the Learnivio exams.
Yes,
When will we have it?
the fortnightly test. So that will happen tomorrow.
No, sir, I'm talking about the midterm exams.
Midterm of Learnivio.
Yes, yearly.
Do we have any midterm exam in Learning?
Yes, sir. My mom got a message that
Okay.
they will start the exams from mid-September.
In September, yeah. So I don't know. I will talk about that and inform you. Oh, good one. So
No, it was about the exams happening in school, so they'll take revision tests.
yeah, it will take what, Aisha?
They were informing that in most of the schools, the half yearly is in September, so they will be taking this.
Yeah, so they'll be taking before that. Yeah, yeah.
But we don't have
Oh,
the half yearly in Learnivio.
You don't have
so it is
what?
not.
It is not what?
I thought, sir, that we have exam in Learnivio, not school.
Yeah. Oh, okay. So, okay. Yeah. Whenever, so it will, you guys will have a half yearly exam, right? In your school. So
Yes,
before that, we will take the half yearly exam in here, right? So that you guys can practice. Understood?
Sir, my half yearly is over.
Yeah. So you guys will have to prepare 4 chapters, right?
yes, sir.
Yeah. So start revising, guys, right? Your school will reopen soon, and then you have so many things to understand and so many things to cover. So please start revising for now, and whenever you face any problem, so I am there. Okay. Yeah. So you guys please log into your Learnivio account and take that active test. Okay. Yeah, and I will call the Learnivio team to make a separate room, and you guys please join in that separate. Okay.
Sir,
Yes, yes, Mali.
sir, there are two tests.
Two. So Kirchhoff law, Kirchhoff law. Take the Kirchhoff law test. Is there any Kirchhoff law?
Yes, sir. And
Yeah.
the
So
other one is motion in a straight line. That
motion of a
I
straight
need.
line is 11th class question, right? So
Yes, sir. But I don't know why it is coming from me too.
oh, your Aisha, your half yearly is already over.
Yes, sir, it took the COVID vacation.
Okay. So how did it go?
They were okay.
Okay. So okay, let us not talk about that. If it, okay.
Yes,
So
like we did only one chapter in the tuition here, so I wasn't able to do the other chapter.
oh, they only asked one chapter. Yeah. Yeah, so there is always a next time, right? So we'll prepare in the next exam. Prepare for the next exam. Okay.
Yes,
Yeah, please log into your Learnivio account and take that active test. So that is on Kirchhoff law. Yes, Rifa, assalamu alaikum. And let me make the